Hi guys, welcome to my channel. And in the last video, we have discussed about the recursion and what is the recurrence relation, and we have talked about the factorial one and the multiplication of two numbers. So in this video, I'll be talking about a new problem, which is find GCD of two numbers using recursion. So what is GCD? GCD is like greatest common divisor. So your input will be two numbers, let's say 4 and 8, and its output would be the greatest common divisor between these two. Like for 4 and 8, it will be 4, because this number is the greatest among the this number is the greatest common divisor of these two numbers. That is why the answer is 4. So how we can go around and solve this? So we can solve this using recursion in, like, let's say let's write a function like GCD, which accepts two parameters. Like this is 4. For example, I'm taking this is 4 and 8. This is, for this example, I'm taking this 4 and 8. So if m is greater than n, so what we are saying, like if 4 is greater than n, 4 is not greater than n, so n is greater than m. This means, so we will call GCD n is greater than, so n is greater than m, right? So if m is greater than n, we can pass m comma, sorry, we'll pass m mod n comma n. And if, I mean else means n is greater than m, so we can write GCD here n is greater than m. Therefore we can write here m n mod m. So this will be our, like this will be our code for finding the GCD. But you can see we have not written any base case. So for finding the base case, let's take an example of 4 and 8 only. So 4 and 8, if I pass, you can see, I'll take this example only. M is 4, n is 8. M is greater than n? No. So here it will come. So I will, and so therefore n is greater than m. That means, so 4 will be here, and 8 mod 4. So this comes to 0. So as you can see, next time it's getting called like m and n. You can see this 4 is m and this becomes 0. So this can be our base case. Like, so what we can write is, like, for base case we can write if m is equals to 0 or n is equals to 0, so you can see, like, if n is equals to 0, we will return m. If m is equals to 0, we will return m, or else this will run. So this is the program of GCD. You can like do this program in much simpler way. Like, I will give you a simple, this I wrote for simplification. Like if n becomes 0, we will return m. So n is like 0, so I will return 4. So 4 will be the GCD of 4 and 8. So if I do it in a cleaner way, so just a minute, yeah, so if I do it in a much cleaner way, it will be like this: GCD m comma n if m is equals to 0, if m is equals to 0, I will return n. If n is equals to 0, I will return m, or else I will call GCD again with, just I missed a return statement here, and GCD I have to return it also, GCD of n mod m comma m. So this is another approach you can use, but for better understanding you can use this. So what will be the time complexity of this? So the time complexity of this will be log of n. Yep, and one thing I forgot to say, like, the time complexity will be order of log of n if n is bigger than m. But if m is bigger than n, it will be order of log of m. But it will be always be log of something constant, log of m or n, because we are always dividing. Like, and what will be the recurrence relation? Let's write the recurrence relation for this. We can say recurrence relation will be like GCD. We can write function f of m comma n is equals to m is n is equals to 0, n is m is equals to 0, or else it will be f of, if I take this n mod n comma m for n and m greater than 0. So this will be our recurrence relation. Yeah, so thanks for watching the video, and the next video I'll be discussing about a new problem, which is like the Fibonacci series using recursion, and also it's like recurrence relation.